In section 1.5, we're going to work on solving literal equations. And the term literal just means that these are equations that involve more than one variable. And this is actually a skill that is going to carry us on through a lot of the algebra work that we're going to do, in particular through the first semester, but in general through the entire class. When we get around to quadratic formula time, there'll be a little bit of this as well. The thing about it is not to get panicky, because you already know how to do this. When you went through Algebra 1, one of the things that you did is you took a general form or standard form equation and rewrote it in slope-intercept form. As a for instance, the equation 3x minus 2y equals 6. If we write this in slope-intercept form, that just means we're solving for y, one of the two variables that's in the equation. So we're going to take that same approach that we learned when solving equations in section 1.4, which is to try to isolate this variable on one side of the equal sign, meaning we're going to undo everything that's been done to it. In particular, I'm saving the y term for last. So I'm looking at 3x. I'm going to subtract 3x. 3x minus 3x is going to go to 0. On the right-hand side, I will subtract 3x as well. So on the left-hand side of the equal sign, I have negative 2y. I kind of step carefully here. The convention in algebra is that we write terms of what's called standard form, so the highest degree term is written first, meaning the variable term comes before the constant. So negative 3x plus 6, even though this side looks like it should be 6 minus 3x. Next, trying to undo multiplication. Y is multiplied by negative 2. We're going to divide by negative 2 on both sides of the equal sign. To make our lives a little bit easier, I'm going to show this as dividing negative 3x by negative 2 and 6 by negative 2. So the left side, negative 2 divided by negative 2, that's just 1. So I have y equals negative 3 over negative 2. Now remember, we're writing this in slope-intercept form, so we want this slope as a fraction. So we actually want to leave it as 3 over 2 times x. And then the last thing I've got is positive 6 divided by negative 2. That's negative 3. So if you can do that, if you were able to do that in Algebra 1, you can rewrite an equation in slope-intercept form. You can solve a literal equation for one variable. So why would we want to do this? Well, let's take a look at one equation in standard form, and we're trying to find a y value for this equation. And we're going to look at it two different ways. The first is we're going to substitute in the x value and then solve for y. The second is we're going to solve for y first. Place it in what my high school chemistry teacher used to call calculator-ready form. Then we can plug x in. So let's try method 1 first. So we're going to take this equation and substitute in the x value. So 2x, and I think we were asked to do this twice, once when x was negative 6, and again when x was 9. So let's walk through the steps. 2 times x, well, x is negative 6, plus 3 times y equals 9. Simplifying, I have negative 12 plus 3y equals 9. Add 12 to both sides. 3y equals 21. Divide by 3, and y is equal to 7. We could do the same thing when x is equal to 9. Substitute, simplify. Nine minus 18 giving negative 9. Divide by 3, and y would be negative 3. So not super challenging. In fact, once we substituted in, we had one less variable to work with. We were working with a number, negative 12 or positive 18. Let's look what happens when we put this in what's called calculator-ready form. I have 2x plus 3y equals 9, and I'm going to solve it for 3y. This is the step that we did at the outset of the notes. Divide by 3, divide by 3, divide by 3. So I get y equals negative 2/3 x plus 3. Now we can plug in. As my teachers used to say, plug and chug. So with the negative 6 being plugged in, y equals negative 2/3 times negative 6 plus 3. So negative 6 divided by 3 is negative 2. Negative 2 times negative 2 is positive 4. 4 plus 3 is 7. Checks with what we had before. If we go ahead and we do when x equals 9, y equals negative 2/3 times 9 plus 3. So 9 divided by 3 gives 3. That's negative 6 plus 3. Y equals negative 3. Same that we had here. You may look at this and not be as comfortable with it because it deals with fractions. If you take the fraction out of the equation, perhaps this is a little bit simpler way to do it, but there's definitely two ways that this can be done. Substitute the value in first and solve for y, or solve for y first and then substitute the value in. So taking a look at some common formulas that are often used in the high school math texts and occasionally end up being used outside of high school as well. The first is the relationship between distance, rate, and time, d equals RT. Simple interest, interest equals principal times rate times time. And the conversion between Celsius and Fahrenheit for temperature. The Fahrenheit temperature is equal to the Celsius times 9/5 plus 32. Occasionally, when folks are changing off between the two, you'll hear them say double it and add 30, which is a pretty close approximation. 9/5 is equal to 1.8, which is pretty close to times 2. We often end up having to rearrange geometric formulas as well. Unfortunately, this didn't reproduce really well on my copy. You might make some notes to yourself on the side off the video from your screen. Area is of a square being side squared. The triangle formula is area equals 1/2 of the base times the height, which remember is the altitude. The perimeter formula for a rectangle, 2 times the length plus 2 times the width, is equal to the perimeter. Area of a rectangle is length times width. And for a circle with radius length r, the circumference is 2 pi times r. The area is pi times the radius squared. So let's go ahead and rearrange a couple of those formulas. So the distance equals rate times time formula. If we were given the distance and the rate and needed to find out the time, we could rearrange that. Distance equals rate times time, and I'm trying to solve for t. Well, t has been multiplied by r, so I need to divide by r, not only on the right side, but on the left as well. So the distance divided by the rate of speed gives the time, and this is commonsensical. If you've driven a long distance, how far do we have to go? How fast are we going? That division gives you the amount of time it'll take to arrive at your destination. The volume formula of a rectangular prism, volume equals length times width times height. Can we rearrange that for h? So I'm trying to solve for h, and I can see that that means I need to divide out by the length and the width. So length divided by length is 1, width divided by width is 1. That gives just the height on the right-hand side. So the volume divided by the length and the width gives us the height. Let's look at one more example. A cylinder. The formula of a cylinder for volume, pi times the radius squared times the height. So let's rearrange that one for h. And then let's use it to calculate a height when we have a known volume and radius. So solving for h means I need to divide by pi and the radius squared on both sides. So volume divided by radius squared times pi is equal to h. The second part of this example asks us, okay, so when we know the volume is given and the radius is given, can we locate the height? So let's use the formula that we just rearranged. Volume, 790. The radius is 5. We'll square that, and then multiply times pi, and that'll give us our height. So 790 divided by 25 pi equals the height. Now, depending on what you're being asked to do, word problem and such, you may be asked to leave this in exact form, to leave pi as is, or you may be asked to use the approximation 3.14, and that's what we're going to do in this example. So 790 divided by 25 as you go to your calculator, and divide that result by 3.14. It's going to give us 10.06. And so we want some units on that, and we don't know exactly what unit we're given. And as far as significant digits, 10.06 is probably a little bit too precise. So we would say that is about 10 units high. So that is rearranging formulas and rewriting and using literal equations to do additional math. So be sure to take a little bit of time and summarize your work. Go through and do your 3-2-1 summary, 3 things that you learned, 2 things that you want to know more about, and 1 big question that you still have. And if you want to sketch or use a graphic organizer, you can do that in the space here below.